Good morning, everyone. This is Kene. This morning, we shall be looking at operators in Python, right? I'm just going to share my screen and we'll get on with it. So here, guys, we started the course, the Python course for beginners, right? And in the last two videos, we discussed all of these, right? Now, this morning, we shall be taking a look at these concepts in Python. Now, what are operators? I like to think of operators as those symbols that indicate actions, right? They indicate operations. Now, the operation will be performed on one or more values or objects. So you need something upon which you would operate, right? So the action is the operation. Now that thing, that symbol that indicates the operation is the operator. And the thing or things operated on, you will call operands. So for example, I had A plus B. Now B would be this plus sign would be the operator, and both A and B are operands. I hope we understand, guys. Right. Now we'll have a look at each of these class of operators in Python. The arithmetic operators. So let's see, guys. Let me just comment something. Arithmetic operator. All right. And that should give us plus and minus and multiplication with division, plus division, exponent, and each other. Now I need to include the modulus. Right. So guys, here are arithmetic operators in Python. We'll look at the uses of these operators. Now I will take the plus. Suppose I had a literal a constant value that I'm going to store in a variable, right? Say num1, and I set that to 6, right? Give it a value of 6. And num2, I give a value of 9, right? So if to get the answer, which I call answer in this case, I'm going to perform the addition operation on these two values, these two constant values, right? So I'll take num1, the variable for that, and num2. So let's see what that gives. We can guess that correctly. So what do we have? That gives us 15. Okay, so that's it, guys. This here is the plus for plus operations, and this is the minus operator for subtraction operations. So if I change this to num2 and this is num1, then I change this to minus. So that gives 9 minus. That will evaluate this expression here. 9 minus 6, that gives 3. And let's see. So that's 3, guys. The same for any of these operators, arithmetic operators. So even if I had this, it would look at the operation associated with this operator and it will carry out the operation. So let's see. Num2 9 multiplied by num1 6. That should be 56. And let's see if we're right about that. 54. Okay, so thank you guys. Now let's go on and have a look at the division operator. Okay, now let's see what we get just by making this division. So we get a floating point number to one decimal place, right? Okay, so that's not a problem. Now, guys, you're going to see something. I'm still going to have 9 and 6 as my values. But instead of doing the normal division, I would use something called truncated division or the floor division. That is, divide and round down the value, the answer. So if I had 5.7, with that fraction, the operation produces or outputs a number and fraction. Then this truncated division will simply return the whole number and discard the fraction. When I carried out 9, when I did 9 divided by 6, I got 1.5. But if I'm using this truncated division, it would give us something different. So you see that it's 1 now. The 0.5, that is the fraction there, is discarded. So that's the thing about this truncated division or floor division. Now let's see this, what this is, the exponent, right? The exponent operator. That will be large, I must say. Okay, now I'm sure we might be wondering what has taken place. So I'll just use I'll use something smaller. I'll call this 2 and call this 3. Okay, so that will be easier to explain. We get 8. So you can see that the exponent is used to carry out multiplication in terms of repeated multiplication by one of those variables as a power, right? So if I had 2 raised to power 3, that's what it means. Num2 is 2 raised to the power of 3. So that will be 2 times 2 times 2, and that gives us 8 here. So guys, just to point out, as they say, there are many ways to the market, right? If I wanted to do this same thing, 2 raised to the power of 3, I could also import the math module. Import, okay, let me just say from math, import power. So that I would simply just say power, that is power. That's the method for it. And it takes 2 arguments here. It takes the number and raised to the power of what? Raised to the power of 3. So let's see what that gives. We still have the 8. Now you notice a slight difference. The how method returns a floating point number, unlike the typical division. So what do? If I need a true integer, then an int, then I'm just going to convert the float to an integer. So let's see, that gives us 8. Remember guys, type conversion, int, we use the int method to convert, say, a float or a string, a number string, to its integer value. Right, thank you guys. Now let's see what this modulus, this is called the modulus operator. Let's have a look at what it does. All right, so suppose I had, say, this case 16, and I divide that by, well, let me say 18, and I divide this by 5. So I have this 18, that is num1 modulus num2. So what would that give? 18 divided by 5. So there's actually a division operation here. 18 divided by 5. But instead of taking the number that is, like the whole number, it discards the whole number and takes the fraction. That is the remainder from which we form, the fraction, which is what is left, right? But using the modulus, we will see that the system discards the whole number, discards what we get, like the number of places that divisor will go in the number that we are dividing, right? Now it returns what is left. So 18 divided by 5 is 3, and there's a remainder of 3. So we'll see that the system will return 3 using the modulus operator. So that gives us 3. So even if I change this to 19, so 19 divided by 5 is 3, and there's a remainder of 4. So it is 4 that is returned. That's the use of this modulus operator. All right, guys, thank you. Now we'll move to the next group, which I would give as logical operators. The logical operators. What are they? So examples here, I could say and, or not. All right, so let's look at them, guys. Look at this. Just consider this statement here. 5 and 7. It will return a value. It will return something that I'm going to store in a variable. 5 and 7. So what do you guys think will be the result, the output? So I would print this out, and we see that we get 7. So why is that? It's going to go from left to right. It's going to check what will be the value of 5 here in terms of a Boolean value. This is true. The false is 0 or false as a Boolean. So if it's not 0, then it is true. If it's something greater than a number greater than 0, then it is true, right? So 5 is true, and provided that going from right to left, this one it encounters first is a truthy, then it will simply return the next. So that's why we have this 7 here. So it's carrying out an operation, right? However, we could also have something like this. Set 2 variables here, num1, which I will call 7, and num2, I will call 9. Then I would ask, now num1 greater than 10 and num2 greater than 3. So I will store this in a variable. I'll call it ans in this case. So guys, now this is something else here. So this will be evaluated, and this will be evaluated before this returns a value and this returns a value. Then the AND operation will now be performed on what we get from this and what we get from this. So the AND will be the last here to be evaluated. Okay. Now, but let's see. What do you think the answer will be? We check num1, is it greater than 10? And num1 is 7, right? So 7 is not greater than 10. This will be a false. It's false. And so for us to say that this, now using the and then I have a false here in the first, the right position, then it's simply going to return false. False is taken to be like 0 and true is going to be like 1. Now using the and, if I have 0 and 1, then it will return 0. It will return false. Guys, please, let's understand it. If it evaluates what is to the right and it returns 0 or false, then, guys, the entire thing, that is, even if it evaluates this and this is true, because this is false, it will return false. The same thing for this. Like the first is the right side, I have true, and on the left side, I have false. It will still return false. So 7 is not greater than 10. This is false, right? So immediately it's going to give us a false value. Let's see if that's right. So we don't even need to check what this is, but let's still do it anyway. Now num2 is greater than 3 because 9 is greater than 3, which is true. So I have false and true. Then what should it give us? It returns false. I hope you guys understand. So even if I turn it the other way, let's say this is true now. So num1 is 7. 7 is greater than 2, and num2 is greater than, so let me make this one false, 11. So 9 is not greater than 11. So here is true and here is false. So true and false still gives us false. So that's it, guys. It's false. But I can make it true. So the two conditions must return true for us to have an overall true, right? So I will have num1 as 7, and 7 is greater than 3. Then num2 is 9, and 9 is greater than 5. So both values return true, therefore I have true as the overall output. So that's it. That's how we use the logical AND, right? Then let's look at the OR. The OR. Just something like this. Okay. Now, what do you guys think? Looking at this first group here, this operator, the greater than operator with its operand, what are we going to have after that operation? So num1 is 7, and 7 is greater than 3. So this is true. Then num2 is 9. 9 is greater than 5. This is true. So using OR, C, true or true will be true. True or true will be true, right? It just returns true. There's no problem about that. So let me comment this and we'll see what we get. So it returns true. Now, guys, I need to say this. If I had true or false, what do you think it will be? True or false? If it is true or false, then it must be true, because we're using or. We need either this or this to be true for the entire thing to be true, right? So if this is true, then the entire operation to the end will be true. Let's see if that's the case. So let me change this now. Let this be false. Num2, which is 9, is not greater than 12. But 7 is greater. So for this place, 7 is greater than 3. So this is true, whereas this is false. But what is returned? That's true. So we see that it is true because the right side is true, and that's all it's going to take. And then even if we had, so this is going to be true, guys. Even if we had false or true, false or true, then that will still be true, right? Then when will it be false? When can it be false? Yeah, so you can guess that right. False and false. So neither return true. So everything will be true. So this, I mean, everything will be false. If neither return true, then all will be false. So this will be false here. False or false. So this shouldn't be and here. It should be or. False or false will be false. So because true cannot come in. Where A is false, and then B is false. So if even if I took A and then I took B and I realized that, oh, both are false, then everything will be false. So let's see, guys. This is false. Num1 is not greater than 10 and num2 is not greater than 12. So both are false. Everything returns false. So that's how we use the or. Okay. Then what about the not? Now the not returns the reverse of the output, right? The reverse of the outcome of that operation. So let's still use this now. We got false from this entire operation here, right? That's false. Now, by simply having the not of what is returned, the entire thing returned, so making that not. So what is the reverse of false? Because this is going to be false. Now, not false, it's not false, therefore means it is true. So our results will be true. Let's see if that's the case. So that's it, guys. Using the not gives you the reverse of the outcome of an operation. That's it. All right. Now, guys. Speaking of and or, there might be a time when we might choose to compare, like do this, look at two or look at a single. Okay, let's say look at two operands now and using the something called bitwise and. We'll see the difference between the bitwise and the logical and. Now, the bitwise and will evaluate that expression at the bit level, bit by bit. That is in terms of zeros and ones, And we'll see a difference between the two, bitwise and logical and. So if I had 7 and 9, right? So what will ands be? What will be the value if I did num1 and num2? What do you think it's going to be? So print that, print the ands. And we looked at it just a while ago. It gives us 9 because this is true, provided that it's not a false value. It will take the second operand to return the second operand. Okay, so what if I created another variable here I called ans2 or bit ans, presenting bits, because I want to use the bitwise and I had num1, and this is the symbol for that bitwise operator, a single ampersand, num1 and num2, right, guys? So let's see what we're going to have there. That gives us 1. So how did we arrive at that, guys? I mean, this, let me print the ans so that we can do the comparison. And this is ans. So here it is 7, and then in the second it is 1. So how does that happen? Now it's going to, let's see guys, I'm going to do something and we will see how we arrived at 1 using this bitwise AND. So I will take bit for num1, bit num1, and I would convert that num1 to its binary value. So let's say bin binary, and I would give 7, right? Then bit num2 with binary. So let me just copy this. Bit num2 and give 7 there as the argument. So just a moment, guys. I'm going to do something. So bit num1, let's just visualize it. Bit num1 and bit num2. Let's see the output. So guys, look at it here. This is the binary for 7, and of course, this is actually the main part here. This is 7 as the binary number, and then this is 9 as a binary number. And guys, remember that I am using the bitwise AND for the binary, right? So true, true, that is 1, 1. That gives me true, right? Then that the next, I move rightwards. 1, true and false for AND. True and false. Guys, remember, cast your minds back. True and false will be false, because if I'm using AND, then both values, both sides rather, must be true. So if I have true and false, I'll get what? False. So that's discarded. True, and for the next again, true and false, I will get false, right? Then here, with a null there, nothing there, so we see that this can be taken to be what? False and true. So nothing there is returned. So I'm left with just a single, I'm left with true. And the integer equivalent of true is 1. This is the only, right after the B, true and true, that is 1 and 1 here, that gives us 1, which is true. So true and true is true. So, and what is the integer value for true? 1. So guys, that's why if I had num1 bitwise and num2, what is returned will be what? 1. So let's visualize that again. What is returned? So I'm going to print bits ans, bits ans, and then we'll see what that gives us. It gives us 1. So guys, this is quite strange, right? So there's a difference between the logical and the bitwise and. If I perform this, just to go back a bit, num1 and num2 using the logical and, we'll see that we'll get 9. It will simply be 9. Yes, that's it. Because it takes the whole thing, the whole number. It doesn't go to the bit level. It takes the entire thing. So it takes 7 and checks. Oh, 7 is true. And once the first is true, it returns the second. And that's why using the logical AND for 7 and 9, 9 is returned. I hope you understand, guys. So enough of logical operators, guys. Enough of logical operators. Let's go to the next. Now I will take the comparison operators. comparison operators. So what are they? To make comparisons, this and this and this and this and this and this. Okay, all right. So guys, what are they used for? This is the operator to check, to compare two values for equality. You compare two values for equality. You use this equality operator. So let's see, if I had a variable num1 and I say it is 15 divided by 5, then num2, I say this is 12 divided by 4. Now, you see that 15 divided by 5 is 3, and 12 divided by 4 is 3. So these two variables here have something in common. They are equal, right? Okay, so let's see, guys. I'm not just simply going to test that and then put the value in a variable. So let's see, num1, is it equal to num2? And let's see what is returned. So I'm going to print ans, and we'll see that is true. Yeah, because this is evaluated and 3 is returned. This is evaluated and 3 is returned. So 3 is equal to 3, and that's true. That's why this gets printed out true. Right. Now, what of not? Not. So let me just explain this. This means not equal to. So if I have 3 and 4, 3 is not equal to 4. So this will return false because they are equal. Do we understand? So 3 is not equal to, but we can see that 3 is actually equal to, so it doesn't satisfy that condition. That is why false is returned. However, if I had 12 divided by 2, so gives this num2 is 6 now, right? So 3 is not equal to 6. Yes, which is true. 3 is not equal to 6. That's true. So what do you think will be returned in this print statement here? I mean, this print method. Let's see. We see that true is returned because this is actually true. 3 is not equal to 6. So that's the use of this not equal to. Now we examine the less than operator. So if this num1 is 3 and this num2 is 6, then I put less than. So is 3 less than 6? 3 is less than 6. So that should give us what? That should be true because 3 is less than 6, right? And if I change this to greater than, now it's now 3 greater than 6. No. 3 isn't greater than 6. So we should have false there, right? Okay, now guys, let's see greater than or equal to. Greater than or equal to. Now, two things there, very quickly. Is 3 greater than 6? No. Then he checks, is 3 equal to 6? No. So no is no. That's like false is false. So this should return what? False, right? Okay, now What if I had 6 here? In other words, num1 is greater than what? Num2. So 3 is greater than 2. So if 1 returns true, then everything will be true. It could be the greater than part, or the greater than operation, or the equal to operation. Just either of them will give, being true will return true. So what are we going to have there? We see that it is true, not because 2 is equal to 3, but because, not because 3 is equal to 2, but because 3 is greater than 2. So if I remove this now and I made it equal to, we'll see that that's going to be false, right? Okay. All right, guys. Now let's see. Let me make this 4 again so that I have 3 and 3. Now, is 3 greater than or equal to 3? It returns false for checking if it's greater than. 3 is not greater than 3. Then it checks the next. Is 3 equal to 3? 3 is equal to 3. And all it needs is just a single true value, right? For everything to become true. So this will return true. All right. So that's it. Now the same thing for the less than, the same thing for the less than or equal to. So this is less than or equal to. So it will still be true because of the equal to, not because of the less than. Okay. All right. So that's it, guys. I hope we understand comparison operators. All right. So we go to the very next one, which is the assignment operator. So I have this and this and this and this and say this, right? And this, and yeah, we could have this as well, but we may not get, I may not be able to get a use case for this operator. So why don't I just take it off? Okay, so guys, here, you know how we assign literal values to variables, right? We assign. So if I had num1 and then with this, this is not saying that num1 is equal to 7. If I wanted to do that, I will use 2 equal to symbols. This is simply saying that 7 has been assigned to num1. That's what it is. So this is an assignment operator. Okay. Sorry guys, just a moment. Num1 has a value of 7. So 7 is assigned to num1. That's the use of the assignment operator. Now, what is this? I think of this as cumulative assignment after addition. Cumulative assignment after addition. So let's see what it means, guys. This here means I have the value of num1, for example, set to 7. Then the 7 is held in num1, right? I will come again a second time and add 7 again to what was stored previously, which is 7, right? So 7 plus 7 is 14. Now the 14 is assigned again to num1. So num1 has a value of 14. Then it comes the third time, and as this, it adds this same 7 to the previous value of num1, which is now 14, the updated value of num1, which is like 14, like, right? So 7 plus 14, 21. Now 21 gets assigned again to the same variable num1. So the new value of num1 becomes 21. Then it comes a fourth time and adds this 7 again. So repeated addition of 7, and the value returned is reassigned to num1. That's what this assignment operator does. Guys, I hope we get it. Now let's look at the use of this in a loop. Let's look at the use of this in a loop. So I'm going to use while loop. While, now I'm going to set I to be 1. Set I as 1. Now, while this I is less than 11, provided that I is less than 11, just print us the new value of I. Just give us the new value of I. That's what I'm saying. So I gets updated repeatedly. So the first time it comes here, this loop, I is 1. The second time it comes into this loop, I is 2. So let's see what that gives us, guys. Oh, sorry. I inadvertently created an infinite loop because I did something wrong. There has to be a way of updating the value of I within the loop. That brings us to the use of the cumulative addition. That is what that has its output assigned, reassigned to a particular variable. So, guys, we see it here now. I becomes, watch, guys, plus equal I. I mean, plus equal 1. Guys, you'll be wondering, so what's this? What's this, guys? You know, I said that this I comes into this loop the first time, it takes a value of 1. 1 gets printed. Then the value of I, which is 1, is added, something is added to the 1. So 1 plus 1 is 2. Then it comes into this loop and prints 2, the updated value of I. Then, since I is 2, I am to add 1 again to it. So 2 plus 1, 3. The 3 is again added to this same variable that is I. So the value of I is updated to become 3. Then it returns into this loop and prints 3. Then it comes to this next line. So the last value of I is 3, right? Now 3 plus 1 is 4. 4 is again assigned to this variable I. And that's how it continues until we see that the value of I will actually increase to a point where it is no longer less than 11 and the loop breaks. So let's see. So we see, guys, 1, 2, 3, 4. And once it gets to 10, it prints 10, then comes out, checks again. I mean, it prints 10, updates the value of I. 10 plus 1, 11. Then it comes here and checks. 11, is it less than 11? No. At that point, the loop ends, it breaks. So, guys, that's the use of this assignment operator here, the cumulative assignment. Now, in terms of addition, now this is cumulative assignment in terms of subtraction. Let's see a use case. So let me make this 10. So we'll go down, we'll reduce. And if I is greater than 0, if I is greater, so I starting at 10, right? If I is greater than 0, decrease, reduce by 1. So let's have a look at it. It comes in here and I is 10, it prints 10. Then it is in this next line, we have 10 minus 1. 10 minus 1 is 9, and 9 is assigned, is reassigned to this variable I. Then it returns and prints the value now, the updated value, which is 9. And then it comes down to this line, performs this operation here, 9 minus 1. That gives us 8. 8 is now again assigned to this variable I. Then it comes back and prints 8. Then it checks again. Okay, it performs the operation 8 minus 1, that's 7. 7 becomes the new value of I. And that's how it continues until I does not satisfy this condition anymore. So I becomes equal to 0, and then it simply breaks. Let's see, guys. So the moment I reaches 0, it breaks. So it doesn't get a chance to print the 0. That's what this is. And we use this assignment operator here, minus plus. The same thing obtains for this, but this time it's just multiplication, right? Let's see. I should make this, say, 1. So if I is less than 100, prints I, then have this multiplied by 2. So now let's see what's going to happen, guys. I starts at 1, it prints 1, right? Then it does 1 times 2. 1 times 2 is 2. The 2 we obtained there is reassigned to I. So I is now 2. It comes out and it returns here. The value of I is now 2. It prints the 2. Then it takes the 2, right? 2 multiplied by this 2 again, which is 4. It stores that 4 in this same variable I. So I now holds a new value. Then it returns and prints 4. Then it takes the 4 and multiplies it by 2. So 4 times 2 is 8. The 8 is stored in this variable again. So the value of I is updated to 8. It comes out and prints the 8. It keeps doing that until the value of I becomes equal to, right? Equal to 100 or more than 100. So once it gets to 100, if it's that case, if it is the case, or more than 100, the loop breaks. So let's see if that is the case. So we see, guys, so I have 1, 2, 4, 8, 16, 64. Now it doesn't give us the next number, the number after 64, because if I multiply, I'm to multiply by 2. If I multiply 64 by 2, I get 128, and it comes here. I is now 128, right? 128 is not less than 100, so the loop ends there. It doesn't get a chance to print the 128, as in doesn't get to print 128 as a number. Right. So guys, thank you so much, so much for your time today. I will continue discussion on operators and precedence and associativity in my next video. I'm sure that will be a lot shorter than, it will be much shorter than this video. So I'm sorry, guys, that this took this long. I'll see you in my next video. Bye.